Hi everybody, today's topic is factoring with a distributive property using no variables. As a reminder, you do not need to write down everything, but be sure to jot down important information and at least one example of each type of problem that we cover. Also remember that you can pause to jot down important notes, rewind to view information again, and fast forward if you think you got it. Just be careful, be sure that you don't miss anything important when you're fast forwarding. Let's begin. As a reminder and review, factors are numbers that can be evenly divided into the original number without remainders. Every number has only a certain amount of factors, which includes 1 and itself. Greatest common factor is the largest common factor shared by 2 or more numbers. And we're going to be using greatest common factors today when we're talking about factoring with the distributive property. This was an example that we went over last time, the factors of 12 and 16. We would list out the factors for both of those numbers, starting with 1 and the number itself on both ends and working our way towards the middle. To find out that the common factors are 1, 2, and 4, so 4 is the greatest common factor. For this lesson, we're going to add on the concept of distributive property. You're going to want to jot this down into your notebook. The distributive property lets you multiply a sum by multiplying each addend, which is the parts of an addition problem, separately, and then adding the partial products. It's going to be very useful later on when we start talking about variables. So today we're not going to talk about variables when we use the factoring and distributive property. Just remember that the distributive property allows you to multiply a sum by first multiplying each part of the addition and then adding those partial products together. So it's like we're breaking it down into two different smaller multiplication problems and then adding together their products, like the partial products method. Here is an example of what we're talking about. So normally we could multiply 5 times 8 and get 40. And the distributive property just basically says 8, since it can be broken down into 6 and 2, 6 plus 2, you could multiply that 5 by each of those addition parts and then add them together. So 5 times 6 is 30, and 5 times 2 is 10, so you can still get to 40 by 30 plus 10. We're finding the partial products, parts of the product, and then adding them together. With 4 times 12, which equals 48, we could break down 12 into 7 plus 2 plus 3. And then that 4 on the outside would need to be multiplied by everybody on the inside. 4 times 7 is 28, but that's not the entire product, right? That's only part of it. 4 times 2 is 8. 4 times 3 is 12. So we can add all of those partial products together to still get the entire product of 48. So that's all the distributive property is. It's telling us that instead of multiplying both those factors together all at once, we can break down one of the factors into pieces and then multiply them separately as long as we add them up together at the end to still get the product. Okay, so let's do some practice with factoring with the distributive property. Here is an example. So we are going to work on this together. Make sure you write this into your notebook. The directions want you to apply the distributive property to factor out the greatest common factor. All right. So here are the steps that you're going to want to jot down that will help us solve problems like that. The first step is to find the greatest common factor, or GCF, between your numbers. Then outside the parentheses, you're going to write the GCF. Inside the parentheses, you're going to write your partner factors. And then you're going to keep the same math operation inside, whether it's addition or subtraction. Make sure that you jot this down in your notes before we move on and show you how to actually follow those steps. Okay, so according to our steps, we first need to find the GCF, the greatest common factor, between 55 and 35. So I'm going to list them down here. I'm going to always start with 1 and the number itself. So I have 1 and 55 and 1 and 35. I'm going to link or connect those factors together. That's going to come in handy later because I'm going to need that factor partner. I'm going to work my way down. 2 can't go into 55. It's not even. 3, I don't believe can go in, but let me try it. 3 times 1 is 3. Subtract that is, so I end up with 25, but don't quite get there. There's a remainder of 1, so 3 doesn't work. 4, I believe, doesn't work as well, but doesn't hurt to try. I end up with 15, and 4 can't go into 15 evenly. I end up with a 3 as my remainder. 5 I know can definitely go in because 5's multiples end with 5 and 0. 5 times 11 will get us 55, so those match up. Let's see, I don't think 6 goes in, but let's try. No, it's 1 short. Remember, you can always use your multiplication table to help you out. Let's see, I only have 7, 8, 9, 10 between these two numbers now. 7 doesn't go in, 8 doesn't go in, and 9 doesn't go in, and 10 doesn't go in. So we reach the middle, okay? Let's try 35. 2 doesn't go into 35 because it's not even. 3 doesn't go in as well. It's a little bit short. 4 doesn't go in. I know 5 times 7 goes into 35. And then in between that, we just have 6, but 6 doesn't work. So we already reached our middle. I'm going to circle my my common factors. So let's see, I think our greatest common factor is 5. Okay. Let me go ahead and delete this stuff so I have room. So I found our GCF was 5. And according to the steps, I have to put the GCF on the outside of my parentheses. Because remember, with the distributive property, we need a number on the outside of the parentheses and numbers on the inside. So I'm setting it up that way. GCF goes on the outside, and inside the parentheses, we're going to write our partner factors. So 5 went on the outside, and then we have to write down what numbers got us there. What times 5 got us to 55? 5 was paired up with 11, so 11 goes here. And then 5 also paired up with 7, so 7 goes here. And then our last step was to keep that addition sign. So here's our answer, okay? Before I hit submit, I'm going to want to double check and see that this actually is the answer. The number on the outside, like we said, has to multiply by the numbers on the inside. So this is the same as 5 times 11 plus 5 times 7. So if this answer is correct, I should get 55 plus 35 at the end. 5 times 11 is indeed 55, plus 5 times 7 is 35. So I do get that question, that original problem at the end. So I should feel pretty confident typing this in as my answer. 5 times the quantity of 11 plus 7. And it's correct, okay? You have to be careful, the order does matter here. If I had 5 times the quantity of 7 plus 11, then checking it, it would not be in the correct answer, or in the correct order. So it would be 35 plus 55. 5 times 7 is 35, 5 times 11 is 55. It is still technically going to give you the same answer, but it's not going to give you the original problem. So we would just have to see if Khan Academy is okay with that. So we can try that on our next one. With addition, the order doesn't matter. Khan Academy should be okay with that, but just be careful if there's subtraction, then the order does matter. So I always like to keep the same order just in case. Let's try another problem. Try this one now on your own. Apply the distributive property to factor out the greatest common factor, 44 plus 48. Pause the video and try it on your own. Okay. We are going to first find the GCF. So that's going to be 1 and itself. And we're going to work our way in. Connect our factor pairs. Those numbers are going to come back and help us out. These are both even numbers, so 2 should go into both of them. This one is 2 times 22, so you should have that down as a factor pair. This one should be 2 and 14, because 2 times 14 gets us to 48. Let's see, 3 won't go into this one. 4 will, 4 and 11. And I believe that's it. So we met the middle. Here, 3, I think, does go into 48. Let's double check. Yes, we have 18, and then 6 times 3 is 18, so that'll give us no remainder. So 3 and, wait. Oh. Yeah, I must have done 14 wrong because 16 can't be smaller than 14. Ooh, this is why you gotta double check your work. 2 times not 14 will get you to 48. Fix that. See, I should just write it out rather than do it in my head. Let that be a lesson to you. 2 times 2 is 4. 2 times 4 is 48. So it should be 2 times 24. Okay. And let me fix these lines so that they're clearer who goes with who. 1 and 48, 2 and 24, 3 and 16. Okay, now 4 does go into 48. That goes in 1 and 2, 12 times. Oh, I hope I didn't run out of room in between. 5 doesn't go into it. 6 and 8 go together. We have just enough room for them. And we know we have reached the middle because 7 can't go into 48. Okay, let's now circle our common factors. 1, 2, these have a lot of common factors. 4, and that's it. Okay, so our greatest common factor is going to be 4. So we already know that number goes on the outside. Okay, 4 was attached to 11 over here, and 4 was attached to 12 over here. So 11 and 12 got to be inside. 4 times 11 got us to 44, and 4 times 12 got us to 48. And we're going to keep that plus sign the same. We can check this by actually multiplying it out. Here is 4 times 11 plus 4 times 12. 4 times 11 is 44, and 4 times 12 is 48. So that does give us the original problem. Now let's try and see if Khan Academy will let us mix up the order. If we mixed up, instead of 11 plus 12, we put 12 plus 11. Okay, they let us put that in. Now that's because 44 plus 48 is the same as 48 plus 44. Okay, it's exactly the same thing. Now, warning, if there were a minus in there, the order definitely matters because 44 minus 48 is very different than 48 minus 44. Okay, so this just involves more of the GCF. You do have to put the GCF on the outside, and you have to keep track of your factor partners here. So be careful and make sure that your work is organized. Make sure your math is good, unlike mine, and it should be pretty okay, these types of problems, as long as you are organized in your work. Let me know if you have any questions as you work on these, and if not, I will see you in class.